The short version asks whether Kimi K3 can build an unreal game. The useful question is harder. What would a real, repeatable system need before we could trust that claim? In this video, we will separate the model, the Unreal control layer, and the validation loop, then walk through one concrete level building example. First, what does K3 actually contribute? Kimi describes K3 as a 2.8 trillion parameter model with native vision, a 1 million token context window, and strong long horizon coding. Its official release also highlights game development and vision in the loop. The model can inspect visual output, reason about what changed, and iterate. Those are relevant ingredients, but they are not an Unreal integration by themselves. That boundary matters. A language model can propose code, plans, and corrections, but Unreal Editor remains the source of truth. The model cannot safely assume that an actor spawned, a material compiled, or play an editor started. It needs a bridge that turns intentions into registered editor operations, and every operation needs an observable result. A credible architecture has 4 layers. K3 interprets the goal and maintains the plan. MCP exposes a constrained command surface. Unreal Editor performs the actual asset, scene, and runtime work. Finally, a verifier reads screenshots, editor state, test results, and logs. If any layer is missing, the workflow becomes a demo rather than a reliable production loop. Now consider a concrete prompt. Create a small Ruin Valley level with a clear start point, 1 enemy, 1 collectible, and an exit trigger. The player must be able to enter play an editor, collect the item, defeat or avoid the enemy, and reach the exit. That is already better than make a cool level because it defines observable acceptance criteria. Planning should produce a task graph, not one giant code dump. The graph might contain level setup, lighting, material assignment, actor placement, collision, input, collectible logic, enemy behavior, exit logic, and validation. Each task should declare its dependencies and its success signal. For example, exit logic cannot be validated until collision and the player's start both exist. Execution should use the narrowest safe tool for each task. Registered asset import tools are safer than arbitrary editor scripting. Structured commands are better than mouse automation when they exist. Guarded Python is useful for deterministic scene edits, but it should not bypass asset safety rules. The goal is not maximum autonomy. It is reproducible control with a clear failure response. This repository already exposes the pieces needed for that control loop. It can execute guarded Python, capture the viewport or the full editor, start and stop play an editor, inspect logs, discover and run tests, interact with Slate UI, import external assets through a registered path, and even generate a dungeon level. K3 would orchestrate these capabilities. It would not replace them. Validation begins before the level looks impressive. First, check structural state. Does the correct map exist? Are required actors present? And are references valid? Then check runtime state. Does play and editor start? Does input work? And do the objective triggers fire? Finally, check presentation. Does the camera show the intended result? Are materials visible? And are there obvious lighting or layout problems? The regression loop should be explicit. Capture a baseline. Apply one bounded change. Start play an editor. Capture the result. Read warnings and errors. Compare the outcome with the acceptance criteria. If the result is wrong, identify the failing layer before changing anything else. This prevents the model from hiding a broken mechanic behind a prettier screenshot. Several failure modes are common. A command can return success while the asset is not saved. A screenshot can look correct while collision is missing. Play an editor can launch while input is disconnected. A generated script can work once, but depend on editor selection or window focus. Long context reasoning helps K3 remember state, but only external checks can prove the state is real. So the final scorecard should separate 4 dimensions. Functional. Can the player complete the objective? Structural. Are assets, references, and saves correct? Visual. Does the scene match the brief? Operational. Can the same run be repeated from a clean state? A good-looking frame is only 1/4 of the answer. A fair K3 test should therefore use the same project snapshot, the same prompt, a fixed tool list, a time budget, and a pre-declared scorecard. Record every command, screenshot, log excerpt, retry, and manual intervention. Then repeat the run. The second successful run is more valuable than the first because reproducibility is the difference between a viral demo and a usable Unreal workflow. The practical verdict is that K3 has the right model-side ingredients for Unreal automation: coding, vision, long context, and iterative reasoning. But the real product is the full loop around it: constrained tools, editor execution, and hard validation. Our next test should measure that complete system, not just whether the model can write plausible Unreal code.